Hi dear students, let's get started to discuss the chapter Chemical Reactions and Equations. As how we see in the name of the chapter, there are two things that we need to understand first to proceed further in this chapter. The first one is chemical reactions, another one is chemical equations. Students, by now we have already learned this topic several number of times, and we are quite aware of what is the meaning of physical and what is the meaning of chemical. Alright, let's just brush up the concepts and get to know about it. See, we know that physical properties of a substance are those properties which are actually visible externally, right? For example, if I talk about the color, size, shape, boiling point, melting point of the substances are all the physical properties. And the chemical properties of a substance are just because of the chemical composition of the substance. That means the chemical properties are those properties which are due to the substance out of which something is made. For example, if I talk about hydrogen, hydrogen is a gas which is flammable, right? It supports burning. It is supporting burning because it is only made up of hydrogen atoms. That is what hydrogen atoms property is. And that's the reason why the hydrogen gas always supports the burning process. Same thing goes true for the oxygen gas as well. But if you mix them together as water, hydrogen gas and oxygen gas, if you mix them together and form a liquid called water, water shows exactly the different property, that is, it is a liquid which extinguishes the fire. That means it doesn't support burning, rather it extinguishes the fire. That means the property of the water is due to this property of water is due to the composition in which the hydrogen and oxygen are present in the ratio of 2 is to 1. Like this, the chemical properties of the substances are only because of the chemical composition of them. That means it is dependent on the substance out of which it is made, or the element out of which they are made. Now, if there is any change in the physical quantity or physical property, I call it as a physical change. For example, if the boiling point of a liquid changes, I say that it is a physical change. If the shape changes, I call it as a physical change. If the shape changes, I call it as a physical change. So any change in the physical property is called as a physical change. And if there is any change in the chemical property, I call it as a chemical change. It is observed that we say that the chemical reaction is occurring whenever we see a chemical change is happening. For example, if I talk about magnesium, we know that magnesium is a metal, and this metal is highly malleable. That means it can be beaten into very thin sheets. So it is already beaten into very thin sheets, and it is drawn into wire, wherein we get something called as magnesium ribbon. This magnesium ribbon is very delicate in its nature. It's very soft. You can cut it with the help of your fingers itself. It's very soft in its nature. So you have to take a small piece of magnesium ribbon and burn it, right? That means whenever there is burning process happening, we say that oxygen is taking part, right? Anything burns in the presence of oxygen. So this magnesium which is there, it also burns in the presence of oxygen and leads to the formation of magnesium oxide. It leads to the formation of magnesium oxide. Magnesium was a metal. It was showing neither, what do you say, acidic nature or basic nature. Oxygen also was not showing any acidic or basic nature. Rather, when you allowed them to combine with each other and form this magnesium oxide, it is observed that this magnesium oxide shows the basic property. It shows the basic property. It becomes basic. Now, apart from that, the other changes that I see is metal magnesium was there in the metallic form, right? In the form of a ribbon. Then when we started to burn, it gave a white dazzling flame. That means there is a color change that is happening, and you also see that there will be smoke coming out. That means there is some evolution of the gases happening, or the and all that stuff. And then coming to magnesium oxide, which is formed, it is formed in the form of a white color powder. That means from the ribbon to the powder form, there is a change in the physical property, that is nothing but the state of the substance. Then the color of the magnesium ribbon was grey color, but then when you see the magnesium oxide, it is a white color powder. That means there is a change in the color as well. So it is concluded that this change is a chemical change because here the chemical composition is changing, right? So that is a chemical change. Now, this chemical change, whenever it is occurring, we say that a chemical reaction has taken place. And whenever a chemical reaction takes place, we see that the physical change also takes place. Now, the physical change can be change in temperature, change in color, change in state, evolution of gas. All these are the physical changes that will indicate that yes, a chemical change is taking place. Now, coming to this change, why do I call it as a chemical change? First of all, the chemical composition has now changed. Magnesium has now changed to magnesium oxide. Apart from that, it is irreversible. I cannot reverse back the reaction telling that I will take magnesium oxide and I'll form oxygen and magnesium from that. That is not possible. That is irreversible. This is irreversible, and that's the reason why it is called as a chemical change. Now, whenever a chemical change takes place, we say that the chemical reaction has taken place. In this reaction also, I say that a chemical reaction has taken place. Now, if I want to tell you that the chemical reaction has taken place, it's okay. I can tell you verbally that this is how it happened, that is how it happened, and this metal reacted with this gas and it led to the formation of this product. It's quite simple. But how about recording it? It becomes really difficult if I want to write like magnesium reacts with oxygen leading to the formation of magnesium oxide, and the state of the magnesium was solid and then it got changed to amorphous form of powder. Gas was there, it combined with it, and all this history becomes really difficult. So we utilize a symbolic way of writing, right? So any symbolic way of representing any chemical reaction is called as chemical equation. For example, this is one chemical equation in which I'm representing the chemical reaction but in a symbolic way. Now, when I say that it is a symbolic way, that means I've used some symbols that I need to understand what symbols are there. If you look closely, we have first this arrow mark, right, which is dividing this equation into two parts. This will become my right hand side and this will become my left hand side due to this arrow. Now, this arrow actually indicates in which direction the reaction is taking place. Children, I told you that this change is irreversible and it cannot be reversed back. It so happens that there are some chemical reactions in which the change can be reversed back. For example, if I talk about ammonia formation wherein N2 and H2 react with each other leading to the formation of two, it leads to the formation of 2N H3, alright. So in this reaction, what happens is nitrogen and hydrogen keep reacting with each other, leading to the formation of ammonia. But then once the concentration is reached to a equal level in both the sides, the reaction will no more be proceeding in forward direction, rather it proceeds backward, wherein ammonia dissociates to give you hydrogen and nitrogen. So in certain cases, the reactions are reversible, right? Certain cases, not all the cases. In certain situations, the reactions are reversible. So this arrow mark which is there, it tells actually where the reaction is taking place, in which direction the reaction is taking place. Here, the reaction is taking place in forward direction, wherein magnesium is reacting with oxygen to give you magnesium oxide. Here, the reaction is taking place in both the directions, forward direction as well as backward direction. That means nitrogen and hydrogen are reacting to give you ammonia, and after a period of time, ammonia will dissociate back to give you nitrogen and hydrogen. So this is the meaning of this double arrow, which says that the chemical reaction is taking place in both the directions, forward as well as backward direction. Now, when I draw this arrow, I know that this is my left hand side now and this is my right hand side now. So whatever is there towards my left hand side, it is nothing but the reactants. This is the reactant side and I have the reactants over here. Reactants are the initial materials which will take part in the chemical, change, and they lead to the formation of product. They lead to the formation of product. So left hand side will be my reactant side and right hand side will be my product side. Now, I have used the symbol plus over here. That means I'm not only taking one reactant, I have taken more than one reactant. Here I have taken two reactants. So whenever I see that there are different materials as the reactants or the products, we basically use the symbol plus to say that there are different things involved in the reaction. So plus indicates how many, like there are more than one or two reactants or products. Arrow mark indicates in which direction the reaction is taking place. Apart from that, we also make sure that we actually write the state. For example, if I talk about this metal, it was there in solid form. So I'll write in the lower case inside the bracket as yes, which indicates that it is a solid. If I talk about this in the lower case in the bracket, I'll write G. Here again, I got the amorphous form, but still it was a solid, so I'll write it as in the bracket S, that is a solid. So this is a simple way of writing, children, in which I get to know which state, which reactant is there, which state, which product is there, and how many reactants were there, how many products were formed, in which direction the reaction is taking place, and all. Now, if we look closely, children, there is a drawback of what I have written. Basically, see here, if I talk about the reactant side, I have taken Mg being one atom. O2, that means there are two atoms of the oxygen, and here I have got MgO in which there is only one atom of magnesium. It's okay, coincides with the reactant. But talking about the oxygen, in the reactant side I have two, but here in the product side I have only one, which is against the law of conservation of mass, which states that the mass can neither be created nor be destroyed in a chemical reaction. Where did my mass go now? That means there is something to be done with this equation, and that is called as balancing. Children, we go for balancing the chemical equation to, what do you say, obey the law of conservation of mass, or to justify the law of conservation of mass, which states that mass can neither be created nor be destroyed. Let us take this one example and try understanding how to balance the chemical equation. Now, to start with, first what I have to do is I have to make sure that I know first how many atoms are there of which element. Okay. Now, to list them down, let's have a hierarchy. We will first write down the metals if there are any, and then we'll write down the non-metals if there are any, and then we'll go for hydrogen balancing, and then we'll take up the oxygen. So this is the hierarchy which we are going to follow, children. Now, if I talk about this equation over here, this chemical reaction over here, I have metal, which is the magnesium. So let me write down the same metal both the sides. That is my reactant side and my product side. And then I don't have any non-metal, so I cannot go for any non-metal over here. Hydrogen, see, I'll tell you one thing. See, oxygen is a non-metal. I completely agree with it. But then oxygen will take it at the end. So that's the reason why I'm not considering oxygen as a non-metal. We should actually take any metal other than hydrogen. Sometimes even hydrogen reacts as both metals and non-metals. So we cannot consider hydrogen. So metals, if there are any, we have to write down first. Non-metals apart from oxygen, there is none. Hydrogen, it is not there in the equation, and oxygen, I do have it both the sides, that is reactant side and my product side. Now I have to list down how many atoms are there. If I talk about magnesium, forget about the product side, children. Let us talk about only the reactant side for now. In the reactant side, I have only one magnesium. And towards my product side, again I have only one magnesium. And if I talk about oxygen, there are two atoms of oxygen over here, and here it is only one. That means there is an imbalance, right? Magnesium is balanced, but oxygen is not balanced. So here the rule is that I cannot change what is written in the lower case. It is fixed. The composition of the different elements in a compound is fixed. So I'll not be able to change it. I cannot change it, but I can add coefficients so that the equation is getting balanced. Now, which coefficient I have to add which side, that we have to look for. See children, here there is a higher number and here there is a lower number. So whatever is there in a lower quantity can be increased, but I cannot bring down whatever is already there, right? So that's the reason I have to make sure that I'm increasing this number in such a way that I get this number over here also. Now what can I do is, if I take this number and multiply by some number, I have to get this number back. So what I can do, I can multiply 1 by 2 with 2 to get 2 back over here. That means the same coefficient to be transferred here where oxygen is present. So I'll write down as 2 MgO. Now after doing this step, let us see what is happening to the number of atoms both the sides. So here I have 1 Mg. But after the addition of this 2, children, we need to note over here, when I add the coefficient at the starting of the compound, it's a compound over here. So this coefficient which is added, it gets multiplied with each element present in the compound. For example, this 2 is for Mg also, this 2 is for oxygen also. That means I have 2 Mg atoms over here and 2 oxygen atoms too. Again, there is an imbalance created. I have Mg2 over there and here Mg1. That means again I need to do something. I need to multiply this number with some number to get this number over here. Again, 1 multiplied by 2 is 2. So the same number should go to Mg over here. So I'll get 2 over there. Now once I do this, what will happen? Very simple. This side, just because Mg was alone, this number simply changes to 2. Now see here, I have 2 Mg, 2 Mg, 2 oxygen, 2 oxygen. That means this is a balanced chemical equation. After we balance the number of atoms, we have to make sure that we mention the states. This I already taught you first, so this equation need not be written with the states now because it is already written. So this is how we balance the equations, children. Let us take one more example to understand it better what can be done. In the next case. For example, children, let's take this. I have Na2SO4 plus BaCl2, which is giving rise to the formation of BaSO4 plus NaCl. Here, let us follow the same hierarchy again, and I have to make sure that I'm balancing the equation here. So let us follow the same hierarchy. This is my reactant side and this is my product side. So what I'll do, I'll write down the metals in both the sides first. The metals here is sodium first, both the sides. We have another metal which is nothing but barium. So we will write barium here also and here also. And then coming to the non-metals, I do have the non-metals. The first one is Cl I have. Then I have sulfur. And then hydrogen is not there anywhere. So I'll go for oxygen. Done. So non-metals I took except the oxygen. So sodium, I could see that there are 2 atoms of sodium. And here there is only 1 atom of sodium. Here I have 1 atom of barium and here I have 1 atom of barium. Cl, if I talk about, here there are 2 atoms and here there is only 1 atom. Coming to sulfur, there is only 1 sulfur here. Here is also only 1 sulfur. If I talk about oxygen, there are 4 oxygens here and here also there are 4 oxygens. Right? Now let us compare and then see what has to be done. For example, if I talk about sodium first, feels like it is imbalanced because this side here there are 2 atoms and this side here it is only 1 atom. That means I have to multiply this number with some number to get this number. And I know that 1 multiplied by 2 will give me 2. That means this 2 will go to the compound where Na is there. This is the only compound towards my product side where Na is there. So I'll add a coefficient of 2 over here. Now once I add 2 towards the product side along with Na, what will happen? Simply the number of sodium and chlorine will change, because this coefficient which is added, it is also for sodium and chlorine. So sodium will become 2, chlorine will also become 2. Right? So now let us compare. I have Na2, Na2, Ba1, Ba1, Cl2, Cl2, S1, S1, O4, O4. Now the number of atoms are balanced. But coming to the state, right? So this NaSO4 which is there, it is there in which state? BaCl2 which is there in which state? BaSO4 which is there in which state? And NaCl it is there in which state? Comment in the comment section and let me know. See you in the next video, students.